Good afternoon, everyone. So, my name's Andrew Barnes. I'm a PhD student in the Department of Civil Engineering and Architecture at the university. And today I'm going to be talking to you about storms, water, and rainfall. I'm currently sat at home in Swindon, which is quite a peculiar town because it lacks any substantial river or water body. Now, we have lakes, we have tiny streams, but we don't have anything that resembles a water like the River Exe or the River Thames. So, where does water actually exist on Earth? Well, if we look at Earth, 71% of its surface is covered in water, but only 3% of this 71% is fresh water, water we can drink. And we also know that most of this fresh water is actually stored up in the ice caps. But in the UK, such a tiny little island, we rarely ever seem to run out of water. So where is it all coming from? Well, to answer this question, many of us will be familiar with that sinking feeling when we wake up in the morning, check the weather, and see yet more rainfall to fall across the UK. Now, despite this, we are all containing that very British excitement of knowing that we get to complain about the weather as soon as we see someone else. Now, this urge may just be a national tradition, but I believe there's more to it than that. Rain has such a pivotal role to play in our society, from filling our reservoirs and rivers with fresh water to causing absolute chaos and devastation through flooding. And we only need to look the past couple of years to see both of these showing up in the news. For example, in 2018, a severe heatwave across the southeast caused a massive lack of rainfall, and this led to reservoirs and rivers across the southeast of England running dry. And this increases the risk of drought conditions affecting places like London. In contrast, we only need to look into February to see when storms Ciara and Dennis tore through the northwest of the UK and resulted in widespread flooding across Cumbria, Lancashire, Scotland. Now, although these events can be devastating, I believe they show just how powerful the weather can be and how not everything may be a storm in a teacup. Today, I'm going to share with you how storms such as Ciara and Dennis are created, how they collect water, carry it across the globe, and dump it here on the UK. And to do this, I'm going to take you on a storm's journey. And in order to do that, we first need to begin with where storms begin. So, looking at the Earth, we have lots of water on the Earth. But around the equatorial line and in the Caribbean and the tropics, this water tends to get hot. And as it gets heated up by the sun or by geothermal radiation, what it does is it begins to evaporate, becoming suspended in the air, making the air very humid. Now, this is the same concept as when you're having a hot bath or shower, and you have all the windows and doors shut. And what happens is the air, once you're done in the shower, is still quite wet and moist. It's like steam coming out of a kettle. And what you find is that this hot air begins to rise, and as it does so, it leaves behind a gap which needs to be filled. So if we take a look at this diagram which shows this happening, what we have is the hot air rising out the middle, and that's being quickly filled by this cold air coming in from either side. Now, as this cold air flows in, it also gets warmer and begins to rise. As the hot air rises, it forms clouds in the upper part of the atmosphere, because the water is cooling down as it rises to the top of the atmosphere. Now, if we were to take a bird's eye view of this phenomenon, what you should see is something that looks a bit like this, where you have all of the air being pulled in equally from all directions, and the hot air shooting out the top towards space. But the problem with this is the Earth isn't that simple, and because the Earth rotates, what you get is something that looks like this. Now here, we have the spiraling pattern of this air being sucked in towards the low pressure center, and as it gets sucked into this low pressure center, it gets shot out the top as warm, humid air. And as it cools down, it then condenses into clouds. And systems such as these are known as cyclones. Now, cyclones that affect the UK at least generally start their lives just off the east coast of the United States and the Caribbean. Now, what happens when they start their lives here? Well, they begin spinning, and what they do is they sort of head northeast towards the UK and Iceland, and as they're spinning up, they take a path straight through Iceland and the UK, normally. Now, what happens here is that these spiral-like arms, which are hundreds of kilometres long, end up sweeping across the UK and other countries across Europe. And what you get then is that these arms are being raised up by the surface of the land, and as they're being raised up, they're getting colder. And if you combine this with the fact that cyclones up here are now pulling in colder and colder air from the poles, as well as this humid air from the south, you get the perfect mixture for rainfall. So, as I mentioned earlier, as water increases, it evaporates into the sky. And the reverse is also true. As it condenses and forms droplets, it can fall as rainfall. And this is exactly what's happening. In this cold mixing with humid air, you get the high humidity water condensing into droplets, which then fall. If you watch your kitchen window or your bathroom window or mirror as you're washing, you'll notice this happen, in that the water condenses on the mirror or the cold surfaces, and if it condenses enough, you get little droplets which form and dribble down the side of the window or mirror. So cyclones such as these are spinning and absorbing more air as they head towards us, and they eventually end up just up here, and they're very cold because they're sucking in all this cold air, but they're also very wet. They're sucking all of this moisture up from the south. So you get the perfect mixture for rainfall. But what happens if your temperatures are particularly cold? Well, if they're particularly cold and you're dragging more and more cold air in, then it could result in hail or snowfall. Now, as I mentioned at the beginning of this talk, I mentioned storms Kira and Dennis. But in 2015, we also had a huge bout of flooding across the north caused by Storm Desmond. Now, Storm Desmond caused complete havoc across the north, south, east and west of the UK. Storm Desmond followed a similar path to Storm Kira in that it started just east of the United States, headed up northeast towards the UK and Iceland. Now, the problem with Storm Desmond is that when it made its pathway up here, it maintained the link of the humid, moist air from the tropics and the Caribbean. Now, as it sucked up this moisture into the storm system over the UK, what you got was this water vapor river. So you got an atmospheric river in the sky, pulling water all the way up to the UK and then dumping it right here. So why does it dump here? Well, for one, you've got the cold air being pulled in. You've got the surface pushing the humid air upwards. But also, remember, the quantity here is important. So you're pulling in a lot of moisture from the tropics still. And what happens here is you end up in almost like a huge atmospheric waterfall of water falling from the sky at the end of this river. So you have this river leading up, ending in a huge waterfall. Now, things like this may seem extreme, but they're not as uncommon as you may think. They're more common in winter, less common in summer. But our research at the university has pointed to the fact that there may be multiple different types of these storms, and the frequency of these storms is changing due to global warming. What can we do to change the frequency or intensity of these storms? Well, not much that we know of right now, but it still leaves some unanswered questions in terms of how these are going to change thanks to global warming. So I hope this journey has shown you just how powerful the weather can be, and I'm hoping whether you feel as right as rain or a bit under the weather, I believe we can all truly appreciate the beauty and complexity of our marvellous British weather. Now, should you have any questions or comments, please leave them down below. I'll make sure to pop on afterwards and comment myself or reply where necessary. But for now, thank you.